Hello everyone, today I want to tell you about the paper called Tree of Thoughts, which might be a good step toward a general problem solving using large language models, but uh, if I think it's not, it's not a general problem solver, but we will see everything during my review. So let's start from a small intro and recap when solving different problems with large language models. We can actually use different approaches. The first one is input-output prompting. It's just a casual prompting where we say you're a good machine and your task is not enslave the humanity. And so basically, we are simply specifying the task and optionally the needed output format. The next approach is chain of thought prompting. Some of you may be already familiar with it, and we ask the model to explicitly make the intermediate steps to improve reasoning. Um, Also, we have self-consistency with chain of thought approach. We just mixes chain of thought with voting. We just make the chain of thought multiple times and choose the best answer by voting. Another concept which is not present in the slide is iterative refinement, where we append to the output from language model instruction, like consider your last answer, how might you improve it, and make kind of a loop to get the best answer. But this paper considers the trio thoughts approach, while existence methods sample continuous language sequences for problem solving, train of thought maintains a tree. Well, suddenly, where each thought is a language sequence that serves as an intermediate step forward in problem solving. Uh, Such semantic unit allows the language model to self-evaluate um, the progress different thoughts make towards solving the problem. And well, by now, as I saw, there is already a graph of thoughts approach and maybe uh, others as well, but I am not aware of them. Um, so for a basic understanding of how it works, let's analyze this plot. At first, we run a chain of thought multiple times, let's say three, as you can see in the slide, and ask the model about first thoughts. Then we use the language models to self-critique these outputs with respect to the input prompt. We just simply ask, do you think that's a good step towards solving the problem? And to choose the best node, we can implement some kind of score, ask the model to label it, or maybe we can just put everything in the context and ask what is the best output. This step relies on hypothesis that language models and even general machine language models are better at evaluating whether two things fit together rather than generating something new. That's why it makes sense to ask the same model whether its outputs fit together and how good they are. And the next step is to choose the best thought. For example, it's the middle one, and again sample multiple thoughts. And we can just repeat this process. Maybe from this plot, you can ask me, but wait, what if all the outputs are bad and the model says it? So, for example, we go here, and we can see that these two thoughts are pretty bad. Well, because it's a tree, we can just backtrack to the previous output, choose the next best thought, and continue sampling from a different branch. So we always expand our so we always expand the branches that has the highest current value assigned. Um so That was intuition, but let's move maybe to the more formalized way of description. And we need to build a three-of thought system. We need to answer four questions. It's how to decompose the intermediate process into thought steps, how to generate potential thoughts from each state, how to evaluate our states, and what search algorithm to use. Let's start from thought decomposition. Depending on different problems, a thought could be a couple of words, for example, if it's a crossword, or a line of equation, if we are using LLM to solve game of 24, or maybe even a whole paragraph of writing plan. But the main point here is that our thought should be small enough so that language models can generate diverse samples, but yet big enough so the model can evaluate its progress toward problem solving. Um, the next part is thought generator. Given a three states, we can use two strategies to generate k candidates for the next step. The first one, we can just sample thoughts from a chain of thought prompt, like we run k times chain of thought and we get k thoughts from it. And this approach works good when the thought space is rich. For example, if each thought is a paragraph, and this leads to a diversity in outputs. And the second approach is we can propose thought sequentially using a proposed prompt, like please give me k thoughts for this problem. And this approach works good when the thought space is like more constrained, and each thought is just a word or a line. So proposing different thoughts in the same context helps us to avoid duplications. The next important part of tree of thought is state evaluator, which evaluates the progress states makes towards solving the problem, serving as a heuristic for the search algorithm to determine which states we need to keep exploring and in which order. In Tree of Thought, we use language model to reason about states, and there are also two strategies how we can evaluate our states either independently or together. The first approach we can the first approach is that we can value each state independently, where a value prompt reasons about the state to generate some scalar values, like a mark from 1 to 10, or a classification label that could be heuristically then turned into the value. So in this work, authors explain that explored the evaluation via a few look-ahead simulations. So like we quickly can confirm that some numbers can reach 24 via simple operations, and plus common sense check, like these numbers are too small to reach 24. While the uh, look ahead simulations might promote good states, the common sense could help eliminate bad states, and such evaluations don't need to be perfect, and they serve in only as approximation. The second approach is we can vote across states, where a good state is voted out based on comparing different states in a vote prompt. When problem success is harder to directly value, it's natural to compare different partial solutions and vote for the most promising one. And the next part is search algorithm, and because tree of thought is a tree, we can use two simple and well-known search algorithm is firstly it's a breadth first search, which maintains a set of most promising states per step. And the second approach is a depth first search, which is explores the most promising state first until the final output is reached or the state evaluator deems it impossible to solve the problem. And You can check the article to find the paper to find a more detailed description of these algorithms for this approach. So you can ask, what are the benefits of tree of thoughts as a method for general problem solving? As authors stated, there are four benefits. The first one is generality. They think that basic prompt strategies like input-output prompting or chain of prompting or chain of thought prompting can be seen as special cases of tree of thought. The second benefit is modularity. We can adjust every component of tree of thoughts, like base language models, thought decomposition step, thought evaluation, and search algorithms. The third benefit is adaptability. We can solve different problems with different language models capabilities and different resource constraints. And the last benefit is convenience, because we don't need extra training, just pre-trained language models is sufficient. Let's move to the experiments. Authors tested the tree of thought approach on three tasks that are hard enough even when using a GPT-4, using standard input-output or chain of thought strategies. These tasks are its game of 24, creative writing, and mini crosswords or 5x5 crosswords. The first task is a game of 24, which is mathematical reasoning challenge, where the goal is to use four numbers and basic arithmetic operations to obtain 24. It's pretty straightforward for us. As for the data, the authors scraped games from 4nums.com and choose a subset of 100 relatively hard games that used for testing. The metric used here is a success rate across all the games. As for the baselines, the authors used input-output prompting with 5 in-context examples, and for chain of thought prompting, authors augment each input-output pair with 3 intermediate equations. Also, for each game, they sampled baselines 100 times to average performance. As for tree of thought setup, authors used breadth first search, where at each step they keep the 5 best candidates. So as you can see from the left table, input-output prompting and chain of thought prompting perform badly on the task. In contrast, even tree of thought with one best candidate achieves 45% of success, while tree of thought with 5 best candidates achieves 74% of success, and that's a huge increase in score comparing to the standard techniques. From the left plot here, you can see how well the tree of thought approach scales with the number of visited nodes. So as we can see how our success ratio increases with number of visited nodes. And the right plot describes the error analysis, and here notably that around of 60% of chain of thought samples failed the task at the first step. Let's move to the next task, which was to creative writing, and here the language models need to invent a creative which to use the 4 sentences in the input to create a passage with 4 paragraphs, which each of them ends in one of these sentences. As for the data, it was randomly sampled from random word generator. It's to form 100 inputs. And as for the metric, to get the ground truth evaluation, authors here used 2 strategies. The first one is using a GPT-4 zero shot to provide one from 1 to 10 scalar value, and the second one is a human evaluation. As for the baselines, they are the same. It's input-output prompting, chain of thought prompting, and also here we can have iterative refinement. As for the tree of thought setup, here I used tree of thought with depth equals to 2, and the language models firstly generate five best plans, and then the votes for the best one. Then we similarly generate five passages and on that plan and votes for the best one again. So here is we are looking for one best candidate. And here are the results for creative writing. Average performance across 100 tasks with GPT-4 evaluation shows that tree of thought is deemed to generate more coherent passages than other prompting strategies, as you can see. However, if we use iterative refinement with input-output prompting, it definitely can help achieve an even better average performance than chain of thought prompting for its task. In human evaluation, people prefer three of thoughts in 41 out of 100 passage pairs. However, there are a lot of cases when people think that chain of thought and three of thought did their job similarly. And the last task is mini crosswords. The data was scraped from Jubix and contains 20 games from it, and also authors used different 5 games for prompting. For each task, the input describes the 5 horizontal and 5 vertical cues. It's like we name we should write something, and here is the description. And so the output should be a board of 25 letters to solve the crosswords. It's obvious. As for evaluation, authors measure 3 levels of success here. It's the portion of correct letters, correct words, and correct games. As for the baselines, it's here the same input-output prompting and chain of thought prompting, and each prompt is run for 10 samples to average the results. As for tree of thoughts, depth first search is used, which keeps exploring the most promising subsequent word queue until the state is no longer promising, and then we can backtrack to the parent state to explore alternative thoughts. Also, here the search steps is equals to 100. And as shown is in the table, input, output prompting and chain of thought prompting methods perform poorly with vote level success less than 16%, while chain of tree of thoughts significantly improves all the metrics and achieving vote level success around 60%, which is a huge increase. But as for portion of correct games, tree of thoughts still have the bad score, but it's definitely better than other methods. It's like 20%. It's 4 out of 20 games was successful, was solved. And yep, and I think that's all. Maybe you have some questions.